Hello everyone. In this video, we are going to discuss about file organization in DBMS. It is a method of storing data in a file format so that they can be accessed efficiently. There are total five different types of five methods of file organization. We will discuss about each in detail. First one is sequential file organization. This is the easiest method of for file organization. In this method, the file is stored one after another in a sequential manner. There are total two ways to implement this method. First one is pile file method. In this method is quite simple, in which we store the records in a sequence, that is one after the another in a order in which they are inserted into the tables. Let us consider there are total four records, R1, R3, R5 and R4. If we want to insert a new record called R2, it will be inserted at the end of the file. In this, sorting is not possible. Let us look into the second way, which is sorted file method. In this method, as the name itself suggests, whenever a new record has to be inserted, it is always inserted in a sorted manner. It can be either ascending or descending. The sorted ways of the sorting of a record may be based on primary key or any other key. So let us consider there are total 7 records, R1, R3 and so on up to R7, R8. If we want to insert R2 into this R2 record into this file, it will be automatically sorted based on the primary key or any other key, and the resultant file is R1, R2, R3 and so on up to R8. So this is about a sequential file organization. Let us observe into the second type, which is heap file organization. Heap file organization works with data blocks. In this method, records are inserted at the end of the file into the data blocks. No sorting or ordering is required in this method. Let us observe clear in this image. There are total of, let us consider 5 different types of record. R1, R5, R6, R4 and last one is R3. They are stored in a different types of data blocks like 144, 152 and so on. In this, ordering is not possible. That is, sorting is not possible. If we want to insert R2 at the end of the file, it checks for the empty data blocks and inserted into the that empty data blocks. In this image, R2 is inserted, R2 and R3 is inserted into the empty data blocks from 189 to 199. So this is about a heap file organization. Let us look into the third type, which is a clustered file organization. It stores related records from different tables together based on a common field called foreign key. So let us understand this clustered file organization with the help of a clean example. Let us consider these two tables called customers and orders. The customers table has three fields like customer ID, customer name and address. In this table, customer ID is the primary key. Now let us consider the second table called orders. Orders has four different fields, which is order ID, customer ID, order date and amount. In this, order ID is the primary key and customer ID is the foreign key. This foreign key customer ID is related to the primary key of the customer table. So if a customer wants to access his entire order history, this cluster file organization combines the both tables using the foreign key and the primary key, and the final resultant table is as follows. It consists of customer ID, customer name, address, order ID, order date and amount. So in this way, this cluster file organization helps to combine two tables based on foreign key. Now let us look into the fourth type, which is indexed sequential access method. This ISAM is a file organization technique used in databases to speed up data retrieval. It is developed by IBM in 1960s, and it combines two different types of organizations called sequential method and direct access method using indices. So let us look into some of the several benefits in this ISAM. It helps in efficient data retrieval. ISAM contributes to the instant access of data by implementing the indexed method, thus avoiding sequential searching. It supports both access method. As I said earlier, it consists of two different access methods called sequential and direct access method. And the third benefit is hierarchical index structure. The secondary indexes with the hierarchical structure helps in avoiding omissions during searching operations of huge databases. So this is about indexed sequential access method. Let us look into the final type of the file organization. It is B plus file organization. Finally, B plus trees are employed to store enormous data that does not even fit into the main memory. The internal nodes of the B plus trees are saved to secure memory, whereas the leaf nodes are written to the secondary memory because of the limited main memory. Basically, the root node is stored into the main memory, and the remaining leaf nodes are stored in the secondary memory. Let us look into some of the properties of B plus trees. The leaves are all at level, means all it consists of only single level. Any child is the root of at least two. Except for root, each node can have at most m children and at least m by 2 children. A max of m minus 1 keys and a minimum of m by 2 minus 1 keys can be positioned in each node. So let us clearly understand with the help of an example. Let us consider this image where 25 is the root node and the values which are less than 25 are at the right side block of the left side block of the 25, whereas values of greater than 25 are at the right side of the 25 of the root node. Construction of a B tree. We begin with an empty tree. We insert records sequentially, adjusting the tree as necessary to ensure balance. Internal nodes contain search keys and pointers to child nodes and leaf nodes, keeping actual data. Second one is searching of B plus trees. So if we want to search an element 17, we compare with the root node 25. The value is 17 less than 25. So we access the left side part of the root node, which is 15. The value 17 is greater than 15. So we access the right side part of the 15 node. And finally, we observe the 17 is present in the right side node of the 15. So this is the searching in B plus tree. Insertion in B plus tree. Create records at appropriate level. If the insertion results in a leaf node to be full, split the node and update the parent node. Ripple up to the root when necessary. Deletion in B plus tree. Place and erase the required record from the leaf node. If the removal results in an underflow of the node, borrow from the neighboring node or merge two nodes. Propagate up to the root if needed. So this is about a B plus tree. In this video, we discussed about the different types of file organizations. Thank you for watching. Please like, share and subscribe. If you have any doubts, please comment. Thank you.